I'm about to give you a complete step-by-step guide to diagnose and fix all the common faults with this Sharp power supply. For those of you who don't know me, I'm Nick. I started Nick's TV Repair about a decade ago and since then have fixed over 27,000 devices. Here are all the components we're going to be installing today. And with those, we'll cover all of the following faults. Number one, the TV is completely dead, no power at all. Number two, the TV shuts itself off after a couple seconds or a couple minutes as if it's overheating. And number three, the error code, 2 slow, 5 fast blinks. I'll have a link in the video description down below if you want to buy the repair kit or just send in your power supply for us to fix. Now the unit that I have here today is one that was sent in by a customer with the dead no power fault. The customer stated they heard a loud pop and the TV went dark. Now, little caveat, the customer did try to replace a few components to fix it themselves, but unfortunately the TV board had another pop sound and then they sent it in for repair. So you will notice a couple components have already been replaced on this board. There are two common ways that we see the power supply fail with the dead no power fault. Number one and most common is with the fuse failing open. So let's do a resistance measurement and see what we get. If it's open or has very high resistance, then it confirms the fuse is blown. But if it shows 0 ohms or just a couple ohms like we are here, then that confirms we have a good fuse and that's most likely not the fault. Now in this scenario, we don't have a blown fuse, but let's assume we do. My next check is going to be on a couple of the transistors here. Fuses don't typically blow unless there is a short somewhere down the line. Commonly, that's going to be caused by defective transistors. So let's check them by doing a resistance measurement. I'm placing my negative lead on the middle pin and my positive on the outer pins. So we're getting about 1.1, 1.2 mega ohms on both the top and the bottom pins. Let's check the other. And for this one, I'm also getting 1.2 and 1.1 mega ohms and rising 1.2. Now, if either of those were shorted, I would have gotten a 0 ohms or close to it resistance measurements, but I did not. So that does confirm these are good. However, again, let's assume they are bad and take it one step further. If either of these transistors have failed, typically it's because of the capacitors next to it. We have C7803A, C7803B, C7804A, and C7804B. Sometimes we'll see little burn marks on the top of those capacitors, and from my understanding, when we do see that, that's actually the cause of the transistors shorting out in the first place. So if our fuse had blown, we probably would have seen a shorted transistor, and if we had seen a shorted transistor, we most likely would see one of those capacitors with a little burn mark on it. When that happens, we'll want to replace all 4 capacitors, the 2 transistors, and the fuse, of course. Now, it's more rare, but sometimes we also see C7817 and C7818 also fail with that burn mark. So as a caution, we're also going to replace those. Now, we're going to start with the fuse replacement. And for this one, the way we're going to replace it is by adding solder and removing the fuse without desoldering it. So what I mean by that is we're adding solder, and I'm going to use these tweezers to pull the fuse out as I melt the solder on the backside. That's our first one. And there we go. Now that the fuse is desoldered, it's going to be a lot easier for us to clear the holes. And I'm going to be doing so with our desolder pump. Now I removed the majority of the solder, but there's still a little bit left, so we're going to get the rest with the desolder braid. And now we can feed through a replacement, so I'll bend the pins. The replacement fuse is physically smaller, but the amperage and voltage rating is the same as the original. We'll do a little cleanup, remove some of that flux from the solder. Now again, the fuse was in good condition. We did not need to replace it, but I'm just walking you through all the steps of how to install the repair kit. Now with that said, if you are going to be repairing this board with the repair kit, it's never a bad idea to preemptively replace the components, even if they haven't failed yet, because all of the ones that we offer in the kits are known to commonly fail, and if yours haven't yet failed, they may be near their end of life and might fail in the next few months. Next, we'll replace the C7817 and C7818. I'm going to be using the same technique. We're going to be adding a little bit of solder first. And actually, we're going to be flipping the board around a little bit just to give me a better angle on the capacitor. And there we go. Next, we have C7818. Same process. And there we go. Now let's remove the excess solder. For these, the joints are much smaller, so I'm not using the desolder pump, just going straight in with the desolder wick. Now both of these capacitors are rated at 331K, 1 kV. Again, we'll feed our replacement components through, and I'm going to be bending the legs on the back side so that when I flip the board over, the capacitor doesn't fall through. So as you can see right here, I have the legs bent outwards. Didn't get great flow there. That's better. Let me touch up that first joint again. There we go. Now we're not going to clean the flux off right now, and that's just because we have several other components in the immediate area we're going to be replacing next. Now these four that are right next to the transistors are all 471K, 1 kV rated, so we'll replace those next. And finally, we'll be replacing our transistors. Now the transistor legs are right here, but this transistor is soldered into the heatsink, which has a leg here, 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 and here. So before we desolder the transistor, I'm actually going to try to desolder the heatsink first. We're going to add additional solder first, and then we're going to use our desolder pump. Now I still have a little bit of extra solder, so again, we're going to use the desolder wick next. And for these, I'm never going to get perfect solder removal, and that's because the heatsink leg is actually twisted at a 45-degree angle, so we need to physically move it back. Same thing with the next leg. And again, it's twisted at a 45, so let's rotate it. Let's see, if I try to move it, yep, we do see movement. Let's see for this side. Yep, we do have movement. Let's do our third leg. And so the reason I wrap the desolder wick around the iron tip is so that I can get better heat transfer between the desolder wick and the iron itself. And again, twist it. Let's see. Yep, it's loose. And finally, the last leg. And actually, I think this one was, yeah, okay, that one just came right out. That one was very loose. And I guess we did a good job of desoldering, and it was not actually twisted, it was straight already. Now our transistor is still soldered to the heatsink, so let's go ahead and keep going. I am picking this leg over here that is a little smaller for the joint, and that one should be pretty easy. Yep, we have a loose leg. That's typically the easiest one to desolder. The other two are usually a little tougher, and so we'll go back to that original technique of let's add solder, and now I'm grabbing the heatsink. I'm going to melt both legs at the same time, and we're going to pull the whole thing through. There we are. So again, now that the transistor is out of circuit, it's going to be a lot easier to clear out those holes and desolder them. These types of joints with that little crown are typically a little harder to desolder. All right, so we'll go ahead and put this transistor over to the side. To save time, because the next one is the same process, we'll do it off screen and we'll reconvene once we're ready to install our replacements. So now that we've removed both of our transistors, we'll need to unscrew them. And something worth noticing is that the way that the legs are bent are actually a little different than the way the legs are bent on the ones that we have. So what we'll need to do is bend them to match the originals. Okay, now it's not quite perfect, but it is pretty close. Something I like to do is remove the old original thermal paste and to apply some fresh replacement thermal paste. So in today's video, we're going to be using the MX-4 thermal paste. That is completely overkill. You don't need to be using high-end thermal paste like that. Typically ceramic 2 works just as well, and we will be including thermal paste with the repair kit. All right, let's screw it back in. All right, that's ever so slightly offset. Let's go ahead and loosen it up again. Shift it a little bit. There we go. And let's repeat that one more time. So again, we're gonna straighten out that middle pin, twist it up, and twist the outer ones a little sooner. Just like that. Get rid of this, clean that up. And I'm using just isopropyl alcohol to clean up the old thermal paste. Same thing I'm using for cleaning up the flux as well. The replacement transistors we are sending in the kit are going to be labeled K20A60U, so they are a little bit higher rated for the amperage, but the same for the voltage. Now let's go ahead and feed the transistors through. So we have to line up the legs, and it looks like I didn't necessarily perfectly line them up or bend them correctly, so we're going to have to do a little bit of an adjustment here. And this might happen to you as well. It is tough to bend them perfectly correctly. The heatsink is lined up correctly, however, so that's good. And our transistor does look to be pretty much as good as it's gonna get for now. So let's flip it over. And before we solder anything in, we're gonna do the same thing. We're gonna retwist the heatsink legs. Make sure the legs are poking through, and I can see all three of the legs. So let's go ahead and lock in the heatsink. And next the transistor. Okay, so this one, the leg is not actually poking all the way through. Let's flip it over. I just want to make sure. Okay, yep, so we're okay there. So as you can see, the third leg is making full contact with the joint, so it is soldered in correctly. Now it didn't go through all the way to the point where I could nicely solder to that leg, but if I put pressure, I am not able to move that leg right there. So that tells me that it is soldered in properly. Let's go ahead and do the next one. So actually, I'm going to learn from my mistake, and I'm going to preemptively bend this more correctly. Okay, I think that'll be better. Let's give that a try. Still a little offset. Okay, that's actually a little better, yeah. And again, I can see both my legs here. My third leg here is not poking all the way through, but we'll be okay. So let's do the same thing. 45-degree angle. Then I think this one was just straight, so we'll leave it as is. Let's double check our joint. So I didn't do this on the last one. I don't think it's necessary, but if you're having a hard time with the soldering of this last leg, you can always actually just solder it from the top to make sure that you are getting good connection between the joint and the leg itself. Again, to be sure, no movement, so we're good. Before we move on, let's go ahead and do that cleaning. Just spraying the whole board with some isopropyl alcohol. And we're going to try and remove the bulk of the flux with the Q-tip first, and whatever we can't get, we'll finish off with the brush. The next symptom we're going to cover is the TV shutting itself off either after a couple of seconds or after a couple of minutes of booting up, and that's going to be pretty straightforward. IC7903 is typically the culprit. That's going to be located right over here. Now there's a fairly simple test you can do, which is to spray it with isopropyl alcohol, turn on the set, and see how quickly that chip evaporates the alcohol on it. If it evaporates very quickly, that does mean that the chip is overheating and needs to be replaced. Another test you can run is to freeze it either with freeze spray or an upside down can of compressed air, and if that allows the TV to run indefinitely as long as you keep the IC cool, then that does tell you that that IC is overheating and does again need to be replaced. Another test you can run is a multimeter test, which I'll show you next. Now before we do the multimeter test, I do want to clarify that the isopropyl alcohol evaporation trick as well as the freezing trick is for the scenarios where that chip has not fully failed but is on its way out. In this scenario with today's circuit board, it actually has fully failed and is why we have the completely dead no power fault. Put one lean on the bottom left pin, pin number 1, and the top right, which is pin number 5, and if the chip has failed, it will show a short or very low resistance. So right now we're reading 12.5 ohms. Now, just like the transistors, that chip doesn't just fail on its own. Usually there's something else behind it. And same as the transistors, typically a blue ceramic capacitor is behind it. Now for this one, we are gonna have to switch over to the microscope. And this one is not super evident, but this is the burn mark that we're talking about. So if you can look here at the very top of this capacitor, and the ID location is C7901. But again, if we focus on the capacitor, we can see there's a burn mark right there. Now, as I mentioned in the beginning of this video, the customer did do some repairs, including replacing the IC chip, but they did not replace the capacitor next to it, which is why the board failed again. They heard that loud pop and had to send it in for repair. Had they replaced that capacitor, I do believe that they would have successfully fixed the issue. Now, something else they noticed is that the resistor just below it here, R7907, had also failed and burnt up. And also for the other resistor over to the left here, which is R7900. Again, they also did try replacing that. And as you can see on the microscope, there is a burn mark on it. And I do believe that the second resistor, R7900, is the one that is causing that loud pop sound. So in this area, we have 2 resistors, 1 capacitor, and the IC chip to replace. So let's start by removing R7907. And for this one, I believe we should be able to desolder it with just the desolder wick. And we should be able to just push it through. All right, and those resistors are out. Now for R7900, if we look at it from an angle, you'll notice that it is soldered into these 2 legs. Those are gonna be much more difficult to desolder. So we're gonna employ the technique we did earlier with the fuse, where we are going to add solder to the legs and then just pull the resistor out, then we'll desolder. Now the customer did already add a bunch of new solder, so we don't technically need to add new solder. I'm just gonna flow the solder they have on there. Here we go, just got the first one. And I think we got, yep, there we go, got the second one. Now there's a lot of solder in these joints, so we're gonna use the desolder pump. I wanna try and get the majority out first before we use the wick. Let's see if we can desolder a little bit more. Hey, there we go. Almost. I actually think that we just have a couple of pieces of metal bent down. Okay, so I'm gonna try and melt that and just fold those back. Okay, there we go. Perfect. All right, let's go ahead and feed our replacement resistors through. So that did not flow very well. Let's cut the lead. Let's add a little bit of new flux, and then let's reflow that. That's much better. Next, for the capacitor, we're going to go back to our desolder wick strategy. And it looks like I might have lifted that pad a little bit. It's perhaps a little too rough. Let's see, let me wiggle this. I do see movement on both the legs. I just wanted to make sure that if I pulled this guy through, it wasn't gonna rip the pad, and it isn't, so we're good. Now this one right here is 101K 1kV. Put our replacement through. So on the left side, we did lift the pad a little bit, but I don't think it's actually gonna be any damage that we need to be worried about. Let's go ahead and give it a quick reflow. And as you can see here, all of these joints are fresh. And again, that's because the chip was replaced. Just going to attack the other side of the chip, or the other side of the legs, and it should be loose. Yep. So we can now remove it. Let's feed our replacement through. So for this one, I do find it that it's easiest to just feed the first 4 legs, and then for the 3 side, we just push them in with our tweezer. I'm gonna keep a finger on it, flip the board over, and same principle, we're gonna push those out just a little bit so that the chip does not fall through. Same thing. Okay, let's go ahead and solder everything back down. And of course, we're gonna give that a thorough clean now. We're gonna switch back to our overhead camera, redo our check. And do we have a short? We no longer have a short. So instead of, I think it was just a 12 ohms or something like that, now we have 36 mega ohms, 32 mega ohms, 29, so it's going down, but this is millions of ohms, so this is far from a short. So I do believe that the IC replacement, the capacitor, and the 2 resistors did actually resolve the initial fault that we were having with this circuit board. Before we do a live test and confirm that the board is working now, let's go ahead and tackle the last symptom, which is the 2 slow, 5 fast blinks. We're gonna be bringing our attention to Q7120, which is this 4-pin component over here. The top pin over here is supposed to produce 13.2 volts. If it is not, then that does confirm that that's going to be your issue. Now, I don't recommend that you try to take a voltage measurement from that pin just because it's easy to slip and cause a short circuit. Instead, I recommend you take the measurements from J7032. Right over here. Now, we're not going to do that voltage measurement quite yet just because for us it's going to be working. So we're just going to go ahead and replace it first, show you how we do that, and then we'll do the voltage measurements after. And let's start with desoldering the heatsink. We're going to add some solder, use our pump. We're going to zoom in a little bit. And it does look like that fell right through. Now this one is labeled KIA378R12PI. This is our replacement, same thing. The pins are not bent, so we'll have to do that. And this one had very minimal to no thermal paste. So of course we'll clean up the original. Okay, next we'll go ahead and bend our pins. We'll add our thermal paste. And screw it back down. All right, and I'm gonna push in the pins a little more. There we go, that's better. We'll give the heatsink pins the twist and solder it all back down. Next, we'll cut off the excess and give it a final cleanup. While we did replace all of the components that we originally talked about, I did find there was a little bit more damage to this board, and we're actually going to end up adding some more components to the repair kits. And more specifically, on the back side, we have a surface mount IC, IC7902. So to give you a reference, these are the components we replaced earlier. If we go to the edge of the board and flip it over, we'll go down just a little bit right there. So we have the label over here, IC7902, with the arrow that goes to this component. The reason I already replaced the IC is because I wasn't sure it was going to fully fix the issue due to the tampering. So I believe the tampering did cause additional damage, including making this chip fail. So we did the replacement. I'm going to show you how we do it so that you can do it at home as well, since we're going to be including this one with the repair kit. As I mentioned, this is already the replaced IC, so it is good and working. So we're just going to remove it and then reinstall it just so you can see the process and technique. I'm gonna start by adding solder all over the legs, and we're gonna go back and forth quickly until we can push it off. We'll use our desolder wick to remove all of the excess solder I added. And if we zoom in on this IC chip, we will see that at the bottom left, there is a little bit of a dot indicating pin 1. And zooming back in on the board, we'll notice that there's the number 1 on the top right. So that means I'm gonna have to flip the chip over this way so that the pin 1 over here matches with pin 1 here. To solder the chip down, I'm gonna add a little bit of solder to one of the pads. I'm gonna melt it and slide the chip in. And now I can add solder to the other legs. I'm gonna add a little bit of flux. We'll touch those up. Now I probably am not using the best size iron tip, so this would probably, I would recommend using a smaller iron tip than I am. And again, another cleanup. Remove that extra flux we added. Now, because I did already replace the defective IC off screen, I was not able to show you what a defective IC looks like. What you need to know is that if your IC7903 fails, that means you probably want to replace that one in tandem with it because they are actually in parallel. So if you're going to be installing the kit and trying to repair the board yourself, that's how I would recommend you go about it. So I'm actually going to add one more set of components to the repair kit, and it's going to be these 4 diodes over here. Now, they very rarely fail, which is why I didn't think about it originally, but we have seen it on occasion, so that's why we're going to include it in the kit. In terms of the replacement, we're not going to show you on screen because it's going to be almost identical to this resistor over here, so it's the same technique, but I'm going to show you what you're expecting to see for the resistance on those. So for this one, I'm going to go in diode mode. These are going to be the 4 diodes just to the left of the transformer. I'm going to put my negative lead on the negative side, positive lead on the positive, and we're getting about 0.4 volts. Let's check this one, 0.4 volts, and we're pretty much expecting that for all 4 of them. When they fail, they will show 0 volts, so it'll be fairly obvious. Now, typically only 1 or 2 will fail. We do recommend you replace all 4, since if one has failed, it is likely that the other 3 are probably near their end of life as well. Let's do a final voltage check and confirm that everything is working as it should. So this connector, what it does is it shorts out my standby voltage to the panel on, the PS on, and the backlight on signals. This way, my power supply is fully turned on without having to be in the TV. I'm going to use the chassis ground for my negative lead, and we're going to check panel 12 volts. That's going to be pins 1 and 2, and that is what we're getting. Pin number 15 is our 5 volts, and we're getting our 5 volts. We have our 13 volt line, and that is present. As stated, you can also check it on the J connector 7032, and that's also present. And I don't think it's necessary, I don't actually recommend it, but we can also check our voltage for the LEDs. And the 3rd pin, we're getting 114 volts. 4th pin, 114. Same with 5th, 6th, 7, 8, 9, 10. This does conclude the full repair and kit installation for this power supply. Again, if you're interested in trying to fix the power supply yourself, we'll have the kit available on our website, and I'll have links for that in the description down below. And if you're not quite comfortable with installing the kit yourself, you can always send in the power supply for us to fix. Again, we do have the flat rate services, which come with a 1-year warranty, and those will also be in the description down below. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.